All right, so we're going to look a little deeper into the boiling point of substances right about now. So what I want you to do is pause this video, and I want you to look very carefully at these, and I want you to match and rank the molecules with their correct boiling points. So pause this video. It's going to take a few minutes, so get out a sheet of paper if you need to, draw some lines across, do whatever you need to, but I want you to rank these substances and try to match their boiling points. So if you need to draw a line and kind of connect it however that works, I want you to draw a line and rank them by their correct boiling points. Okay, welcome back. So here they are now ranked, so I've reordered them into their correct boiling points. And let's go over why these exist the way they do. So helium is a single, very, very tiny atom, so their dispersion forces are incredibly weak, which means that its boiling point is unbelievably low at 269. Absolute zero is negative 273, so if you wanted to try to liquefy helium, you'd have to cool it down to within 4 degrees of absolute zero. The H2 molecule, hydrogen gas, is also incredibly weak because hydrogen atoms are the smallest atoms in the universe. And so this dispersion force is incredibly small. Neon is also a single atom that happens to be, because it's one shell further out than helium, bigger, so it's going to have a warmer boiling point. And by warm, I mean negative 246 below zero. Nitrogen, N2, has a boiling point of negative 196 Celsius. That is unbelievably cold. And yet, you may have heard of liquid nitrogen. I got something to show you later on about that. To liquefy oxygen, you need to cool it down to negative 183, just a little bit higher. Now you'll notice that as we move into larger molecules now we've got diatomic molecules, that boiling points start going to go up. So look at methane. Methane has 5 atoms. They're small atoms, but they have 5 atoms. So a methane molecule is larger and has a greater surface area that can allow for these induced dipoles to occur. And so its boiling point, negative 162. Then when you get to carbon dioxide, you get a molecule that has 2 highly electronegative atoms to it, 3 atoms total, and it spreads out, giving a nice area for induced dipoles to occur, and thus its boiling point, negative 78 Celsius. Still pretty cold because it's still nonpolar, but nonetheless, it is higher than the others. As we move to propane, we've now got 11 atoms, so you can see it's much higher at negative 42 Celsius. As we move to butane, we've moved to 1 because we've got 14 atoms. Now all of these, from helium down, these are all non-polar gases, but they are ranking higher in their boiling points as these atoms get larger and larger. As we move to C2H5OH, that is ethanol. And ethanol has this OH, which makes it a polar molecule. And because it's polar, notice its boiling point is significantly higher at 78 Celsius. 78 Celsius is really warm. We're talking on the order of about 180 degrees, something like that. Water has an even stronger dipole interaction known as hydrogen bonding, so its boiling point goes up to 100 degrees Celsius, or 202 Fahrenheit. And then sodium chloride is ionic, and as an ionic compound, it is the strongest intermolecular force that exists, and so it has an incredibly high boiling point. All right, so let's talk a little bit more about liquid nitrogen. It's kind of cool stuff. So since liquid nitrogen, or nitrogen gas, has no polarity, its molecules can only interact through very weak dispersion forces. So it doesn't condense into a liquid until 196 below 0 Celsius. You're not going to do that in your freezer. You need a very special unit for that. So at 196 below 0, that's really cold. That's enough to freeze you solid. That's enough that you've always probably seen these things on the internet of people dipping like a rose or a ball into liquid nitrogen and it's shattering. If it's that cold, then how did this man do this? How did he stick his hand into liquid nitrogen and not have severe frostbite as a result? You've probably seen this classic trick. In this case, this person took a cup of coffee and dipped it into liquid nitrogen and then threw it, and the cup shatters into pieces. The paper cup shatters into pieces. Now the coffee is melted. How did he stick his hand in there then? I'd like you to watch the video that I have attached to the classroom called the Leidenfrost Effect. It'll go over how he did it. All right, so now you know how to rank the boiling points of substances based on their intermolecular forces. Ionic compounds are going to have the highest boiling points. Polar compounds are going to have a medium boiling point. Nonpolar compounds are going to have the lowest boiling point. If they're all nonpolar, you're going to rank them by the size of the molecule, with the smallest molecule having the lowest boiling point and the larger molecules having higher boiling points.